Welcome, ladies and gentlemen, boys and girls. Today we're going to solve one of the coolest questions, which is first bad person. So basically, what the question is saying like you are working in a product manager company. Okay, you develop a new product. Unfortunately, the version is not good. It fails the quality check. Okay, so you have to check you have to check the previous version, all the version after a bad version. Okay, so basically what they're saying, let's just say we are working in a Google. Let's just say, okay, we will work in Google. Okay, so it's saying like we develop something, let's say Android iOS. So for example, if the Android iOS version, let's say 1.4 is bad, okay, so let's say for simple, I say my version 4 is bad, but if we produce any version after this, if I produce version 5, version 6, they all will be bad because there is a defect in version 4. So the after this version, all version will be defect, and before this version, let's say we have version 1, version 2 and version 3, they all will be good. Why? Because the first defect occurs in version 4. Okay, so this was the question saying like we have to detect in which first version the defect has come. So if you look at this input, they're saying n equals to 5, so the n is 5. So it means we have 5 versions: version 1, version 2, version 3, version 4, version 5. Okay, so it's saying like the defect occurs in version 4. So we have to return the 4th version. Okay, so that's how it will look. So now you're asking like how we're gonna solve this question. So for this question we will use two approaches. One is linear search, which could exceed the time limit, and another is binary search, which will go faster than anything else, because this is go O of log n, this takes O of n. So hopefully this will go 100%. Okay, so let's just see how we're going to solve this question. So I hope the question is understanding what the question is saying. So I give you a little good example. If you don't, then don't worry, then I will explain you the dry run of the code. All right, so let me just erase everything over here. And so first of all, like we are working on the linear search. So first of all, I will show you the linear search approach. Okay, so just in case you want to know, okay, how you do it. All right, so first of all, what I do, I will simply run a for loop from int I equals to 1. Okay, because if you look at over here, they are saying the version start from 1 till n. Okay, so I will run this loop from I1 till I less than n. Okay, but I will increment, and I will call one if condition. I will say is bad version. Now say what that is. Okay, so basically, like how can you detect like whether the version is bad or not? So they call it, they have given an API called bool is bad version. So this bad version API help us to detect which version is bad. Okay, so we just have to put the condition over here and it will detect which one is the first one, which one is bad. Also I will say is bad version, and it's my n. So if it's I, so whatever the first bad version I will find, I will just simply return over here, return I. Okay, and we have written something over here as well, so I will simply return n over here. Okay, for instance, like, because if we don't return, then it will give an error. Right, so let me just run this code and let's see it's gonna working or not. And here we go. So it's accepting the runtime is 1 millisecond. If the test case are very worse, if you look at over here, the constraints can be go up to about 31. I hope so this will go time limit exceed. I hope so. And taking a time, let's see. And here we go, guys. So it's got time limit exceed for this input. Okay, so as I told you, like linear search is not an optimal approach to solve this question. So what I will do, we will use binary search to solve this question. Now you say like, dude, how the binary search will help? Okay, so let's just say we have something like I told you, like we have version of like 1 2 3 4 5 6 7 8. Okay, and we you know how we use the binary search, if you know. So we create one low over here and we create one high over here, and then we will calculate our mid. Okay, so this mid will be this one. So it is even, so it can be this one or either this one. Okay, let's say we call it this one, and our version defect is the number 5th. So this is our 5th version is defected, let's say. So our say like defect is 5th. Okay, so now how we going to calculate? We will first of all calculate mid, and we will check. So like which is mid, we will check is mid is a defect version or not. So we will say no, mid is not a defect version. Then what I will do, I will stop looking at these one, because it means like if mid is not a defect version, then you know what it means. So it means like before the mid there is no defect version. So it means before the mid there is no defect version. So mid, the defect version can be after the mid. Okay, so what I will do, I will just simply move my low. Okay, my mistake. I will simply move my low from over here to a mid plus 1 over here. Okay, I hope you know how the binary search work. If you don't know, then check out the video of binary search I have created. Okay, all right, so I move over here low. So now I will again calculate the mid. So we have how many? 1, 2, 3, 4. The mid will come something over here. So yeah, maybe let me move my mid. Okay, so the mid will go something over here, if I'm not wrong. Yeah. 1, 2, 3, 4. Yeah, 4 by 2. So 2 even. So let's say mid will come over here and even. Okay, then I will again check. Is mid is on the defect version? I will say yes, mid is on the defect version. So what will happen? My high will move from over here. So it means like after my mid there is all the defect version. So what I will do, I will take my mid, I will take my high from the end to put it with the low. So mid -1 till mid -1. So you know, like low is equals to mid +1 and high is equals to mid -1. If you don't know, don't worry, I will show you in the code, don't worry. Okay, then what I will do, I have these two values now, okay, remaining. So these all rest of them are ignored, so they all are ignored now. So I will calculate the mid again, and I will find my mid will come over here because 2 by 2 is 1. So I will again calculate, I have again calculated the mid, my mid will come over here now. Okay, so right now I will check, is my mid is on the first bad version? I will say yes, it is on the first bad version. So this is the first bad version, and I will just simply return it. Okay, so I hope this thing is clear, like how we're gonna do this. So let's just start solving our question, right? Okay, so first of all, what I have to do, I will create one my int low, which is initially at 0, and I will create my int high, which is at n, right? And one I will create my first bad version. I will call it FBV, which is initially -1, let's say. Okay, so I will run my loop, and I will say while low is less than equals to high. Till then my loop will run, and in this one I will calculate my mid. So it will be low plus high divided by 2. Okay, guys, that's how we calculate. But let's say if for say like if our constraints are very bad, then I will just optimize it a little bit more. Okay, guys, like this, and here we go. So now what I will do, I will create one if condition. I will check if I will call my bad version. So I will simply put it over here. Is bad version is mid. If we are on the bad version is mid, and it's true. If it is true, then what it means my first bad version will be equals to mid. Then it means like I hope so we find the first bad version is mid, and I will decrease my high from the, I will decrease my back from till mid, because after my mid it means like everyone are damaged one, everyone are defected one. So I will just simply put high equals to mid -1. And so let's say that's not the first defective version. The defective version might be before that. Then what I will do, I have to because like before that what I will do, like I have to move my low as well. So I will move my low, because like before my mid there is all are good version. So it means like there is no possibility of a bad version. So low equals to mid +1. Alright, guys, and finally we have to return first bad version. Okay, I hope so the code is very simple based on binary search. I hope so you know binary searches. Let me just run this one as well, and taking a time a little bit depending on the server speed. Is going saying 10 maybe exit. I think we did a little mistake. Okay, now okay, so now it's running. I think because of the brackets, so I just remove the brackets now. I hope so it will work now. Let me just submit it, finger crossed. Let's say it will go correctly, and here we go, guys. So this one is in this one we are dealing with time conversion off log n, so it depends on the server speed. So sometimes if you see like is runtime, you will see a definitely difference over here. Okay, so that in this one I think in this one I got the runtime of 98.29%. So you see, so like it depends on the server load. So never mind. Okay, so I hope the both approaches are clear to you, like how we did it. So if you still have any doubt, then just do let me know in the comment section. I will definitely gonna reach to you. And if you don't understand this video, I'm suggesting try to watch this video again. You will definitely gonna understand. So ladies and gentlemen, I just want to say thank you very much for watching this video. I will see you in the next one. Till then, take care, bye bye, and I love you guys. Please hit the like button if you like this video. All right, bye bye.